All right, so we're going to do matrix row transformations, and this is to get it so we can get our matrix into the row reduced echelon form so we can see what x equals, y equals, and z equals really easily. So, for any augmented matrix representing a system of linear equations, the following row transformations can result in an equivalent system of linear equations. Any two rows can be interchanged, so we can switch two rows, doesn't matter which one is top and which one is bottom. The elements of any row may be multiplied by a non-zero constant and it doesn't change anything. And any row may be changed by adding to or subtracting from its elements a non-zero multiple of the corresponding elements of another row. So really what we're doing is we're doing solving a system of equations, and all the things we did there we're doing with a matrix, but now it's in a different format. It's the only thing that's different. So Gauss-Jordan elimination can be used to transform an augmented matrix into a row-reduced echelon form. Its objective is to use these matrix row transformations to obtain a matrix that has the following reduced row echelon form, where A and B or A, B, and C represent the solution. So we're going to have a matrix that starts out kind of looking maybe sort of nasty, maybe not, depends. And what we want to do is get it into this form or this form when we have a 3 by 4. Okay, so we want it to get to be ones down the diagonal and zeros everywhere else. So what we want to do is here use Gauss-Jordan elimination to transform this system of equations first into an augmented matrix and then put that into the row reduced echelon form. So first we'll put that into a augmented matrix, and that's just again 1, 1, 1, 21. 2, 1, 0, 23, and then 0, 1, 3, 25. And so that starts our thing. Now, what we're going to do is we want to get ones down the diagonal, zeros everywhere else. So we're going to say this is going to be kind of like our starting point. If we get that to be a 1, what we can do is we can get everything below that to be 0 next. So we'll take a minus 2 times this row plus this row, and then that's going to be the new this row. So if we take a minus 2 times that, it's going to be minus 2 plus that's going to be 0. Minus 2 times that's going to be a minus 2 plus that is going to be a minus 1. Minus 2, that becomes a minus 2, and then and so on. And so that's how we're going to work it. And then we're going to try to get all these to be 0 first, and then we'll go next to get that to be a 1. And then we'll get everything down here to be 0, and then we'll get, that to be a 1. And so we'll see how that all works. So we're going to replace row 2 with the sum of row 2 and negative 2 times row 1, kind of what I was telling you about. And kind of a thing to do is I always write out stuff so I know what I've done. So what I'm going to say is, let's say we're going to take a minus 2 times row 1 plus row 2, and that's my new row 2. So that way I know what I've done. Because if I go from here to here, I don't know what I've done here unless I actually, was doing it. If I look at your work, I will never know what you've done here. So let's write this out like this. So we're going to take a minus 2 times this row plus that. So in our head, we can do all that, and that's not a problem. But this tells us what we've just done. Okay. I mean, they've written it out in the long form here, but this gives us a nice abbreviated form, and then we can say, okay, well, now we have that. Now the next thing we need to do is we need to make this a 1. So I'm going to say, uh, well, and say now they're saying take row 2 plus row 1, but they're going about this in a backwards way usually. Usually you start here and you work your way down and get all the ones down here, and then you work your way up. Works either way, it doesn't matter. But now they're saying, okay, well, now let's take row 2 plus row 1. Okay, so if we do that, what happens is that becomes 0. Then we make those smaller, and then we have that to be 0 as well. Because again, our whole goal is to have those up here 0 and those down here 0. So it doesn't really matter which way we do it. So the next thing I would do probably is take that plus that. So they're now they're going to say, okay, let's take a minus row 2, and so we have this, and we have positives on that row now. And now we're going to take a minus row 1 or minus row 2 plus row 3. So now they're kind of adding in these items that I do, but now they're going to say minus this plus that. Well, at this point we could have said, at this point we could have just said instead, let's take row 2 plus row 3, and that's our new row 3, and that would give us this. Okay, so now we've got ones down the diagonal, we've got zeros here, but we don't have zeros here. All right. So this is called row echelon form, but it's not row reduced echelon form. So now what we need to do is make those to be zero. And so we're going to take, again, I'm going to say, let's write it as this way. Let's put it where we're going. Row 3 plus row 1 becomes our new row 1. And so we get that. And now I'm going to say, let's take minus 2 row 3 plus row 2 as our new row 2. And so they kind of wrote that part, but then they don't say, what they've done here to make it the new row 2. And so now we've got this in the final form. Now this is the row reduced echelon form, so we can say that x, I think is what we were using. Yeah, x is equal to 8, y is 7, z is 6, and so that is our solution. Okay. And again, I'll do some examples later and show you kind of more detail on how I would do it straight going down. And this is kind of how the book is showing in our book. So this is kind of what we're showing here. All right, so let's pause there. We'll come back for some more.